Good morning, sir.
Good morning. New setup today. दिखाई दे रहा है?
Yes, sir.
Yes, sir.
सुनाई दे रहा है?
Yes, sir.
नॉइज आ रहा है किसका? बंद करो भाई। इसका नॉइज आ रहा है, बंद कीजिए ऑडियो। हेलो।
sir.
हेलो।
Yes, sir.
यस सर।
Yes, sir.
Hello?
Yes, sir.
Yes, sir.
Shall we start?
Yes,
Some
sir.
okay.
Yes, sir.
56, 30 भी नहीं है on average. सब होली मना रहे हैं, वेरी गुड. ओके, तो हम लोग लास्ट क्लास में पढ़ा रहे थे जो लैप्लास इक्वेशन, ये दिखाई दे रहा है ना?
Yes, sir.
Yes, sir. Yes, sir.
Now, so we have already expressed the quantity, these two quantity. Okay. So now, last में हम लोग क्या किए थे? We have taken two parameters. One is R dot and another is R. याद होगा आपको, ये R dot जो है which is define the volume surface, मतलब अगर हम ड्रॉ करेंगे तो we have a volume or surface or linear charge which is situated at, let's say, R dot, and we are interested to find out the electric field at a point whose coordinate is R. Okay, so now we know that this is actually, ये R2, ये क्या बोले थे हम लोग? ये R1 R2 बोले थे ना लास्ट क्लास में?
Yes,
Yes, sir.
R dot और ये R1 है. और हम लोग ये किए थे, so this is, if I say this is R, इस तरह का R है, then we know that it is R1 minus R dot. है कि नहीं? So this is your direction of R cap. So let's say if this is your R, then we can write this one also. So this is, मैं simplicity के लिए बता रहा हूँ, ये R mix ना हो जाए. So ये R जो है, this is the direction, this is this vector. Okay, the distance between the center of gravity of the charge distribution to the point of interest where we are wanting to find out the electric field or potential. So this is, we have already calculated it, 1 by 4 pi epsilon 0. क्या था? ये डिपेंड करता है, अगर मैं वॉल्यूम इंटीग्रल लूंगा, so it should be, so this is a function of r. यहाँ पे जितना भी कोऑर्डिनेट है, you can express in terms of r dot. Okay, so that means it is actually, if I say it's a volume charge distribution, so you have to do the volume integral, then it is a function of r, and then d tau, so that means you have a small volume d tau here. Okay, and divided by maybe ये r होगा ना, r है ना, ये r square है, and we have to put one r cap here. Okay, so if I don't want to put r cap, if I want to put r vector here, so it will be r cube. समझ में आ रहा है?
Yes, sir.
Okay, so now this one similarly 1 by 4 pi epsilon 0. So if I do the volume integral, ये टोटल चार्ज यही मिल जाएगा आपको, ये आपका r dot का फंक्शन है, this is total charge. So now it will be just R. Okay. Since it is a scalar quantity, okay, if I put a dot coordinate, let's put dot here. Because I am putting dot here. So let d tau for convention it will be function of x, y, z or something, or t tau dot is actually tau which is function of x dot, y dot, z dot. It's a dot coordinate or a non-dot coordinate. ये याद रखिए.
Excuse me, sir.
हाँ बोलिए.
सर ई वेक्टर सर जो उसमें सर डिवाइडेड बाय आर क्यूब लिखे कि आर स्क्वायर लिखे सर?
वही तो मैं कह रहा हूँ. If you put r vector here, then it will be r cube. Or if you put r cap here, so it will be r square. So now it's similar. Okay, we know that r cap is r vector divided by
Sir.
r. बोलिए.
Sir.
समझ में आ रहा है? मैं अगर यहाँ पे पुट करूंगा तो ये r divided
Sir,
by r.
Your voice is very low audible, sir.
You cannot hear me?
Not audible very clearly, sir. Very less, sir.
Okay. Hello. Now you can hear me.
Sir, your voice is not audible, sir.
The video is also not that much clear.
How it is possible?
Sir, it is clear, sir.
Google Meet is not working actually. I don't know what happened. Okay, speaker, Jabra. Yes, it's working.
Working, sir, working.
Working very well.
Yes, sir.
My side. And then noise suppression. Okay, let's put auto here. Logitech camera. Very good. Okay. ठीक ही तो है.
Yes, sir, ठीक.
ठीक है ना. मेरा साइड से तो ठीक दिख रहा है बाबू. अभी दिख रहा है.
सही है.
Okay, okay, very good. So now, this is what we have learned up to now. After that, we have shown that if you calculate this one, del square V, okay, this will give you the Poisson equation. 1 by epsilon 0 into rho. Rho is what? Rho is function of r dot. Okay, dot coordinate. So this is called Poisson's equation. Okay. So now, if there is no charge enclosed, so that means rho r dot will become 0, then this will become 0. इसको हम लोग बोलते हैं लैपलास इक्वेशन और इसको हम लोग बोलते हैं पॉइसन इक्वेशन. लैपलास इक्वेशन समझ में आया? So now, suppose जैसे मैंने बताया था, suppose you have a volume, okay, volume which is enclosed by a surface S, let's say this one, okay, and there is no charge here inside the volume, let's say rho equal to 0. Then you can apply this Laplace equation to find out. If you solve this one, solve will give you V equal to V. Okay, so now for this situation, let's say if we have a volume, okay, which is enclosed by surface S and it enclosed also some charge, rho is not equal to 0. Then we have to solve this one to get here. Okay, these are two situations. जहाँ पे जो आपका वॉल्यूम है, in which you are interested to find out the potential, if it contains charges, okay, maybe bound charge or maybe free charge, I will come to that later, you have to use Poisson's equation. And if you consider that the volume is not actually contain any charge, so in that case you can use simply Laplace equation and solve it to find out the potential. समझ में आया? Okay, so that means for rho equal to 0 is in everywhere in the volume, inside the volume. ठीक है, तभी जाके ये होगा. दिस इज योर क्या बोलते हैं, whatever we have taught, this is the summary. Okay, so now our job is to find out, use the Laplace equation to find out what is the potential for a particular problem. Next job जो है. So let us little bit discuss about what is Laplace equation in detail. So this is your Laplace equation. So if V equal to VR, R मतलब क्या है? R is what? If I say this is R is Ix plus Jy plus Kz. So this is a position vector, okay? So that means it is a function of coordinate only. The function of coordinate only. That means if it is follows the Laplace equation del square V equal to 0, and if we solve it, it will give you.
So
Yes.
what have you written? So function of coordinate.
Only coordinate only. Coordinate और कुछ नहीं है, velocity कुछ नहीं है, charge bar कुछ नहीं है, ठीक है? So now if I solve it, it will give you V, which will be function of, let's say, if I say Cartesian coordinate x, y, z, okay? If I use Cartesian coordinate, it will be maybe r theta phi. If I use spherical polar coordinate, so it will be V function of r theta z if I use cylindrical polar coordinate. Okay, so this is for Cartesian coordinate, and this is for spherical coordinate, and this is for cylindrical coordinate. So that means solving the Laplace equation, this problem will become a symmetry problem. So it depends on the symmetry of the object in which you are studying the electrostatics. Okay, suppose if you have a box, okay, let's say it is a box, and you put this box, let's say it is a solid box, maybe dielectric made of quartz or something. So you put this one in an electric field, okay?
So what have you written? The cylindrical coordinate.
Cylindrical coordinate r theta z. Okay. So that means if I put a box which has a rectangular parallelepiped set. Okay, so that means it has a Cartesian symmetry. Okay, in 3 dimensions. Okay, so then if I put in an electric field, then there will be some polarization inside, dielectric polarization inside the box. So that means practically we have put this one in an electric field, but there is no charge enclosed. So we can apply Laplace equation here, and if I solve it, you will get the potential as a function of x, y, z. Similarly, if I put a sphere, okay, in an electric field, okay, similar problem, sphere. So in that case, if I want to solve similar situation will be here also, because there is no charge enclosed. We have just put the sphere in an electric field, so there is no charge here. So if I want to solve this one, so in that case we have to use this spherical coordinate system. Now similar way, if you have a cylindrical, let's say a cylinder, you put a cylinder in an electric field. Okay, so if I want to solve this one, so you have to use cylindrical polar coordinate. So now the game is shifted to mathematician who knows very well to handle this kind of coordinate systems. Mostly Cartesian coordinate systems, spherical or cylindrical. These are the 3 shapes we usually see around us. Okay. But there are several systems also which doesn't come into these shapes, usual shapes. So in that case, we have to use curvilinear coordinate system, and bataya for arbitrary system. But that this is not a simple issue. So you can use curvilinear coordinate system, E2, E3 like that, in 3 dimension. So it is curvilinear coordinate. Curvilinear कोऑर्डिनेट मतलब इसका जो 3 axes है they are curved, not straight line. Okay, I am not going to teach all these stuff here, but you should know that what are the branches coming out from here. This Laplace equation not only true for electric potential, it is also true for any function which is coordinate, which is a function of coordinate only. Suppose temperature. So temperature is actually a function of x, y, z coordinate only. Okay? So now suppose if you have a bar, okay, and you want to find out the temperature distribution inside the bar, metal bar or metal cylinder or metal sphere. So you can use this equation del square T equal to 0 to find out the temperature distribution over a maybe this for the mechanical people, maybe this might be much more interesting for you to solve this Laplace equation for temperature function, not the potential function, but they behave same because this is mathematically they are same. This is also function of coordinate. This is also function of coordinate. Okay. So maybe in the second year we will learn the Fourier heat flow equation, where it's nothing but a Laplace equation in 1 dimension, 2 dimensions, or 3 dimensions. But they are same actually. Mathematically they are same. So maybe in that case, suppose if you want to find out the Fourier heat flow equation for a rectangular bar, maybe you can use Cartesian coordinate. Maybe if you have a cylinder, you can use this one, or maybe if you have a spherical thing, you can use spherical coordinate system, or if you have any arbitrary system without any particular set, you can use curvilinear coordinate. So these are the things maybe you can remember for your future study. Okay. So this is how the Laplace equation is very much universal. It's not only applicable for electric potential, it works for any potential function, maybe temperature, maybe electric field, maybe magnetic, electric potential, magnetic potential, any kind of any thermodynamic potential, you can apply Laplace equation. Okay, this is all. Now so we don't know these coordinate systems. We don't know the spherical polar, cylindrical polar coordinate, curvilinear coordinate. So we will not discuss this three coordinate system. Instead, we will just use Cartesian coordinate system. Maybe in the beginning of the course, I taught how Cartesian coordinate system works. पढ़ाया था ना इसे? हेलो?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
ये दो
आ
तीन
रहे।
पढ़ा था, सिलेबस में नहीं है, but maybe in second year your teacher may teach you. Okay, so let's stop here and try to solve it in case of Cartesian coordinate only, not for others. So now, what is the operator? This operator, del square operator. What is del square operator? So I have already told you this operator works like this. Okay, it is not like that. Suppose if you have a function, you work on that one del operator, again you work on another del operator, not like that. Instead, you can do one thing. Let's say d dx plus j d dy plus k d dz dot again I del x plus like this. So if I do so, you will get del square del x square plus del square del y square plus del square del z square. So this is your del operator, del square operator, Laplacian operator. We call it Laplacian operator. Okay, so that means, so if I say that so now you have to consider the dimension. Okay, let's say if we say that okay, the potential is only function of one coordinate, not x, y, z. So in that case, your Laplacian operator will be just this one. So, and your Laplace equation will be just del square v divided by del x square equal to 0. So since v is only function of x, so there is no point of writing partial derivative. It will just become it's complete derivative. Dx square equal to 0. So we know that how to solve it. So we call it it's in one dimension. One dimension. Laplace equation in one dimension. Okay, so it just becomes del square dy. So because v is only function of x, so you don't have to put partial derivative here. It will become just a complete derivative. So now we know that how to solve it. We did it many times in your class 2 courses. So let's do it. So if I solve this one. बताइए इसको सॉल्व करेंगे तो क्या देगा आपको? क्या करेगा ये सॉल्व करेंगे तो? दो बार इंटीग्रेट कीजिए, इसे क्या होगा? डेल स्क्वायर v बाय डेल एक्स स्क्वायर इक्वल टू 0. एक बार इंटीग्रेट करेंगे तो क्या होगा ये? del v by del x equal to, let's say, mx. It will become mx. Only one constant will come. Okay, क्या होगा ये? सॉरी, constant होगा, only constant. Let's say c1. Okay, so now if I do another derivative integration, so it will dv C1 dx. Okay, so if I do integration, you will get another constant here. So it will give you V C1x plus C2. So it will just give you a straight line y equal to mx plus C4. So if I write this one V equal to, let's say, mx plus C. So it will just give you a straight line. So that means, so now it is not the complete solution because we don't know what is the value of a and c. So that means in Laplace equation solving, it's very important to have boundary conditions which will provide the value of two arbitrary constants. See, if you have a second order differential equation, second order differential equation. So if you have a second order, so you will get two constants. If you have a first order, you will get a one constant. So order will give you the number of constant. Now, the problem or whatever you say, it is something like that. So the boundary condition should be exactly same as boundary condition will be same as it is depicted. Suppose if you here, it is a two-dimensional, one-dimensional problem. It's a differential equation of second order. So there must be some boundary, the number of boundary conditions should be something like that, which will provide the value of this two. So now, if you know that, suppose if you have a two variable and if you have a two equation, it will give you exact solution. Suppose if you have a two variable, one equation, you have a two variable, three or more equation, these two cases will give you not unique solution. हेलो पढ़ा है ना आपने?
Please explain.
Explain it once, sir.
Yes, suppose if you have two variables, 2x plus 3y plus 5, maybe x minus maybe 10y equal to maybe 50. See, you will get the unique value of x and y only when the number of variable is equal to the number of equation. Okay? In similar way, here also we have two variable constant here. So a and c. So we have to provide some boundary condition which is actually equations. Okay, like this, which will give, which is the number of boundary condition will be equal to the number of the constant, arbitrary constant, which is derived from the Laplace equation. Otherwise, we won't get the unique solution. Okay, जैसे मैं बता रहा था, सपोज इसका एक दो वेरिएबल है y दो वेरिएबल है एक इक्वेशन, इसका सॉल्यूशन क्या है? Nothing but a straight line. There are many solutions. Okay, similar way if I say for 3y7, so maybe x minus 3z equal to 10. If you have a three solution to a three equation or more equation and two variable, then also you won't get one unique solution. You will get a lot of solutions. Okay, okay. So that means the number of, it's very important to get a unique solution. You need to have number of variable and number of equations to be same. Otherwise it will not work. Similarly, here also there are uniqueness theorem for the boundary condition in solving Laplace equation. There are two boundary uniqueness theorem which will actually dictate what will be the boundary condition for Laplace equation. Okay, I will come to that later. So let's just take some boundary condition and try to see what is the solution. Okay, so it is given that, so now it is, so you cannot stop here, it doesn't mean anything until unless you don't know the value of a and c, these two boundary conditions. So you need to have a boundary condition. Let's say the boundary conditions are One boundary condition are, let's say v x equals to 1 equal to 4, and let's say v x equal to 5 equal to 0. So these are the two boundary conditions. So now if I put this boundary condition here, so see मैंने define नहीं किया what is the volume, what's the surface. So mathematically मैंने बता ही दिया कि this is the boundary condition. So see, you have two arbitrary constant and you have two boundary condition. So it will follow the same rule. Two variable, two equations, so you will get a unique solution. And we can see that it will give you unique solution. So if I put this boundary conditions, so this will give you the value of a. आप solve करेंगे, so it will give you the value of a equal to -1, and it will give you value of c as 5. ओके आप देख सकते हैं उसमें कोई प्रॉब्लम नहीं है. देन योर v विल बिकम क्या होगा -x + 5. ओके सो नाउ यू कैन सी दैट v इज ओनली फंक्शन ऑफ x which is -x + 5. ओके सो दिस इज द सॉल्यूशन. So this is a unique solution. It only depends on x. So that means if I know the value of x, you can find out the unique value of v. Okay, so this is a unique solution. Unique का spelling क्या है? unique solution of Laplace. Why it is unique? Laplace. Because for each value of x, you will get one unique value of v. That is why it's a unique solution. Okay. वो ठीक है ना? समझ में आ रहा है मैं क्या कह रहा हूँ?
Yes, sir.
Okay, आना चाहिए. It's not so difficult. So now if I plot this one, आप लोगों ने EDOF वगैरह सॉल्व किया था, तो उसमें प्लॉटिंग वगैरह था, how to plot a function. So ये मतलब ये इसका स्लोप -1 है. इसका मतलब क्या है? ये डिक्रीजिंग फंक्शन है ना?
Yes, sir.
So
Negative.
I plot this one. So let's say this is your x, or let's say this is your vx. If I plot this one, so x should, when x is 0, so it should be 5. Okay, and when v जब एक बाउंड्री कंडीशन में पुट कर रहा हूँ, जब x इक्वल टू 5 है तो v का 0 है, और जब x इक्वल टू 1 है तब ये x equal to 1 है. Let's say this is 1 2 3 4 5 1 2 3 4 5. So जब x equal to 1 है तब y equal to 4 है. 2 3 1 2 3 4. Let's say 4 3 4. So like this. So this is your solution. Okay. So now जो मैं कह रहा था why it is unique, because for each value of x, let's say this is x equal to 2, you will get a unique value of maybe y, whatever, a v, which is 3 or something, whatever we have to find out from here. So this is what Laplace equation for one dimension, and it will give you a linear solution, and if you have a unique boundary condition, you will get a unique solution. That's all. So now before going to, so now this is for one dimensional case. Now for two dimension in Cartesian coordinate system, that means you have to have a lamina type of thing. So there will be two coordinate x or maybe y. So in that case, your Laplace equation will become del square v divided by del x square plus del square v divided by del y square equal to 0. So this is the Laplace equation in 2 dimension. So if I solve it, so v will become function of x and y. So that means you can find out the distribution of v over the whole surface. यहाँ पे आपने क्या मिला? The distribution of v along the whole length. Okay, like this. So यहाँ पे भी solve करें. तो अभी one dimension में problem नहीं है uniqueness का. Okay, because it is just a total derivative. So v d to v by dx to equal to 0. It is a total derivative. The uniqueness problem comes only when the velocity, the potential is a function of two parameters, more than one. So we have to deal with partial differential equation, and this uniqueness solution problem only related to the partial differential equation. So now we have to discuss what are the uniqueness theorem for boundary condition. If I want to solve a difference, if I want to solve a Laplace equation in 2 dimension or 3 dimension like that. So similarly, you can write down this one in 3 dimension also. So here you will have, since we are describing Cartesian coordinate system, so it will give you this kind of parallelepiped symmetry. So let's say this is your maybe z or y or z x or something like that. So that means if I want to solve this one, your Laplace equation in 3D will be something like that: del y square del 2v by del z square equal to 0. So if I solve it, so v will be function of x, y, z. So any particular set of value of x, y, z, you will get a one unique solution for v. So let's say there is a point, let's say this one. This is 1, 1, 1. So here also for each point, let's say for 1, 1, 1, you will get a one solution for v 1, 1, 1, not two solution. You need to have a unique solution, because ये अगर ये यूनिक सॉल्यूशन ना हो तब प्रॉब्लम हो जाएगा, बिकॉज प्रॉब्लम ये होगा जो आप लोगों ने पढ़ा था कि दो इलेक्ट्रिक फील्ड लाइन दे कैन नॉट क्रॉस हियर. So that means so if you have a two electric field line, if they cross here, suppose, so you have a two direction. Okay, if I put a tangent, then perpendicular to the tangent, so you will get a two direction here, which is not possible. So that means in one point you will have a two electric field or two potential, which is fundamentally not true. So that means solutions should be for each point you must have only one solution, not two. Suppose v के लिए, suppose 1, 1, 1 point के लिए you will get only one solution. Similarly, if I say this is 1, 1, so for v 1, 1 you will get only one solution, v 1 like that. जैसे वहां पे भी हर एक x पॉइंट के लिए आपको हर एक सॉल्यूशन मिल रहा था, यहाँ पे भी मिलना चाहिए. Okay, so this is the need of uniqueness theorem in solving Laplace equation. So let's discuss what are the uniqueness theorem for Laplace equation. यहाँ तक समझ में है, आ रहा है? Why you need uniqueness theorem? Because if you don't have uniqueness theorem, you can have more solution in one point. So if it is true, then you will have क्या बोलते हैं उसे, value two potential or two electric field in one point, which is not fundamentally true. So let's move.
सर म्यूट हो गया.
सर
सर माइक
Hello?
म्यूट हो गया।
हेलो
यस
अभी
Yes.
सुनाई दे रहा
yes,
है?
yes.
सो ये समझ में आ रहा है मैं क्या कह रहा हूँ?
Yes, sir.
सर।
So why you need uniqueness theorem actually? Otherwise वो एक पॉइंट में दो सॉल्यूशन आ जाएगा. So first uniqueness theorem, uniqueness, spelling uniqueness. Theorem. ये कुछ बड़ी बात नहीं है. It's a simple thing we are already practicing. The first uniqueness theorem says that, let's write down because it's a theorem, you cannot put your own word here. So write the word, what it is written here. The solution of Laplace equation in some volume, let's say the volume is V, is uniquely determined, uniquely determined if V is specified on the boundary surface is. ये बहुत ही सिंपल सा स्टेटमेंट है. मतलब आपके पास एक क्लोज्ड सरफेस है, ये क्लोज सरफेस एस है जो कि ये वॉल्यूम को स्पेसिफाई कर रहा है. दिस इज द वॉल्यूम. ओके, इट सेज दैट द सॉल्यूशन ऑफ द लैप्लास इक्वेशन इज यूनिक. मतलब एक पॉइंट में इसको आपको एक ही सॉल्यूशन मिलेगा. जो मैं बार बार बता रहा हूं, ऐसा नहीं होगा कि यू विल हैव टू सॉल्यूशन इन वन पॉइंट. जो मैं बार बार बता रहा था कि यही है फर्स्ट यूनिकनेस थ्योरम. सॉल्यूशन मस्ट बी यूनिक इफ the volume is enclosed by a closed surface. Okay, so this is what you can prove it very simply. Let's say there is two solution exist. Okay, तो आप क्या कर सकते हैं कि two solution exist है. let's say two solution exist. Okay, separate, two distinct solution, not the same, distinct होना चाहिए. Distinct solution exists. Let's say they are V1 and V2. Okay, so if they are distinct, so there must be third solution, which is the difference between two. Okay, because superposition principle आप लोगों ने पढ़ा है क्लास 2 में कि अगर कोई जगह में वोल्टेज V1 है, if you cause another voltage V2, another voltage V3, the total voltage will be the superposition of all these three voltage. सुपरपोजिशन प्रिंसिपल पढ़ा है ना, चार्ज के लिए, वोल्टेज के लिए, फील्ड के लिए पढ़े थे ना क्लास 2 में.
Yes, sir.
नहीं सर प्लस 2.
तो वही है. तो अगर ये भी है तो सॉल्यूशन एग्जिस्ट कर रहा है तो इसका डिफरेंस भी आएगा जो कि ये मिल सकता है. ये भी एक सॉल्यूशन होना चाहिए. must be a solution also. Must be a solution also. Because that the superposition principle demands so. So now if they are solutions, so they should obey the Laplace equation. That means del square V1 should be 0 and del square V2 should be 0. So they should, if they are the solution of the Laplace equation, so they must obey Laplace equation. They must obey Laplace equation. So now what we can do very simply, we'll just operate this one with del square operator both sides. So you have V3 equal to V1 minus V2. So let's operate del square operator both sides. So del square V3 equal to del square V1 minus del square V2. Okay, now we know that del square V1 equal to 0 minus del square V2 equal to it is 0. Okay, so that means which means actually which, so if this is a solution, so मैं उल्टा कर रहा हूँ. So if it is a solution, मैं कह रहा हूँ if it is V3 also a solution, so it should also say obey the Laplace equation like this. Okay, so now if I put this one, that means del square V1 minus del square V2 should be 0, which will give you V1 equal to V2. So that means whatever we have considered earlier, that there are two distinct solutions. If I go forward, so it seems that they are not distinct, they are equal. So that means that is how it gives you unique solution. समझ में आ रहा है लॉजिक?
यस सर.
सर वो टू डिस्टिंक्ट सॉल्यूशन कंसीडर किया है ना.
हाँ, हम लोग ये क्या बोल रहा है देखिए ना, if you have a volume enclosed by surface, then this theorem said that the Laplace equation should have a unique solution. Okay, and to prove this, I am considering that we have two distinct solutions exist. Okay, V1 and V2. So if V1 V2 are distinct, separate, different, so their difference will be there. There will be a difference between them. Let's say this is V3, which is V1 minus V2. So now superposition principle says that, so their difference will also give you a solution. Must be a solution also of Laplace equation. If it is so, Laplace equation का solution हो तो ये भी उसको obey करेगा del square V3 equal to 0. जैसे ये V1 V2 सॉल्यूशन है Laplace equation का, तो ये भी इसको फॉलो करेगा, इसको obey करेगा. So now we know that V3 equal to V1 minus V2. Now if I operate del square operator both sides, so it will give you this one. So now we know that del square V3 equal to 0, which gives you del square V1 minus del square V2 equal to 0, which gives you V1 equal to V2. So that means whatever conjecture we have considered before, that they are distinct, and we see that they are not, they are equal. So that means obviously you will have a distinct solution. To prove this one, we have taken the help of superposition principle. Superposition principle. If linear superposition principle does not work, then we cannot say that they are different. Difference will also be a solution. Okay? समझ में आ रहा है?
Yes, sir.
Yes, sir.
Okay, let's go for the second uniqueness theorem. वो भी ऐसे ही है, बहुत इजी है.
Last part, don't rub the last part, sir.
क्या क्या क्या?
तो सर रुक जाइए 2 मिनट.
Okay, okay. Second theorem. मैं लिखता हूं उसी के लैंग्वेज में, थोड़ा बड़ा है. ए वॉल्यूम V surrounded by surrounded by conductor and containing specified charge density rho and containing specified charge density rho, the electric field. ये थ्योरम जो है ना रूट्स के लैंग्वेज में लिखने की कोशिश करिएगा, people love it. Electric field is uniquely determined if the total charge on each conductor in each conductor is given तो मतलब यहाँ पे टोटल चार्ज जीरो नहीं है, ठीक है। यहाँ पे टोटल चार्ज मतलब जीरो, मतलब यहाँ पे चार्ज डिस्ट्रीब्यूशन है, ओके। सो बट द चार्ज डिस्ट्रीब्यूशन is actually not inside the, let's say you have a surface, let's say.
Sir,
Yes.
so can you dictate this function?
Repeat कर दो.
Yes, sir.
Even volume of V, okay, surrounded by conductors and containing containing specified charge density, okay. The electric field is uniquely determined if the total charge in each conductor is given.
Thank you, sir.
ठीक है। सो नाउ मेरा कहने का मतलब है, जो सपोज आपके पास एक वॉल्यूम है, मतलब पहले क्या बोला था, एक फुटबॉल ग्राउंड था, ठीक है, कोई गड्ढा नहीं था इसमें, और गड्ढे नहीं है तो चार्ज भी नहीं था, तो रो इक्वल टू 0 है, ठीक है। सो नाउ वी हैव ए फुटबॉल ग्राउंड एंड बहुत सारे गड्ढे हैं, और ये गड्ढे में चार्ज है रो 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 रो। तो और ये इंसुलेटिंग सरफेस है, गड्ढा का जो बाहर है ये इंसुलेटिंग सरफेस है, ये इंसुलेटिंग सरफेस है, ये इंसुलेटिंग सरफेस है, ये इंसुलेटिंग है, और बाउंड्री तो है ही, ठीक है। तो ये भी इंसुलेटिंग सरफेस था, ठीक है। तो ये और ये इंसुलेटिंग सरफेस, और इसमें चार्ज है आपका, ठीक है। चार्ज लेट्स से मैं बोल रहा हूं कि रो ए, इसका डिस्ट्रीब्यूशन रो, लेट्स से हर का डिस्ट्रीब्यूशन सेम है, लेकिन वॉल्यूम अलग अलग है, जो गड्ढे का जो डेप्थ है और एरिया है अलग अलग है, तो इसलिए अलग अलग वो चार्ज कंटेन कर रहा है। लेट्स से यू हैव ए क्यूए चार्ज हियर, देन ए क्यूबी चार्ज हियर, देन ए क्यूसी चार्ज हियर, देन क्यूबी चार्ज हियर, समथिंग लाइक दैट। सो नाउ so this मतलब ये जो ये बाहर का जो एक्सक्लूडिंग बाउंड्री है, you can put this boundary according to your need.
एक मिनट अच्छा,
हाँ बोलो।
আপনি পড়াচ্ছেন?
या
একটা কথা বলবো, এই আপনি পোস্ট করে
না করে পড়বো ভাবছি, লোকজন ঠান্ডা দিচ্ছে।
আমরা পড়বো না ভাবছি, তুমি না বলে আমরা পড়বো না, কি করবে সেটা তাই আমাদের বলো।
লাস্ট ডেট রেজিস্ট্রেশন করেন, কি করবেন বলুন।
ইউনিভার্সিটি এটা লাগবে না, এমনি তো আমি লাগবে কি?
কি ব্যাপারটা একটু পরিষ্কার করে বলবেন, মানে কেন লাগবে, কি কি করতে
না না একটা थोड़ा म्यूट, एक मिनट सुनो, रुको, मैं थोड़ा म्यूट करता हूँ। हाँ, थोड़ा थोड़ा 2 मिनट रुको, ठीक है? ये कैसे म्यूट करता है? इधर हेलो, तुम लोग हो कि चले गए? हेलो,
है सर, है सर, है सर, है
है सर।
है सर, है सर।
क्लास छोड़ के कहाँ जाएंगे सर?
what we are trying to say that, so that means ये you can put this boundary, the outer boundary, outer